All right, so welcome back to California State University Northridge Chemistry 101 Lab. Today we're going to go ahead and go over experiment number 6, which is the analysis of unknown solutions. So there's not much to really show you today as far as technique goes, but I'm going to go ahead and go over some of the concepts to help you prepare and do the pre-lab questions, as well as prepare for your pre-lab quizzes. So, experiment number 6, if you'll go ahead and turn to it into your lab manual, it should be around page 54 or 55. What we're going to go ahead and go over is the basic solubility rules and how to use the chart to figure out if things are going to be soluble or insoluble. Now, what's going to happen in this experiment is you're going to get a set of 5 solutions, so you'll get 5 vials, and it'll be one of the sets listed in your lab manual. So it'll be either set A, or set B, or set C, or set D. You're not going to have mixing and matching in between the sets. Now, those compounds in there, you are going to first check their pH to kind of figure out which ones are acidic and which ones are basic. And then you're going to use the acidity and basicity to determine which set you have. After that, you're going to use the solubility rules to figure out which set is which, or which solution is which. Now, if you look at it, the chart is split up into 2 sections, those that are typically soluble, those that are typically insoluble. Now, if it is soluble, that means that it is almost completely dissolved in aqueous solutions, meaning you're not going to really be able to see it unless it has some sort of color. Now, if it is insoluble, that means it'll form something solid when it is in water. So you'll actually see something like cloudy or hazy and with solid particulates falling out of solution. Now, if we look at it, the top half, you have nitrates and acetates, which have no exceptions. So the column on the right of that table is telling you that there are no exceptions to any nitrate or acetate containing solutions. So those are always soluble. Now your halides, chloride, bromide, and iodide, are typically soluble unless it's with one of 3 heavy metals, that being silver, mercury, or lead. If it's a sulfate, it is also typically soluble except with the 4 exceptions listed. And those are strontium, barium, and again, mercury and lead. Now, if we look at the things that are typically insoluble, you have sulfides, you have your carbonates, you have your phosphates, and your hydroxides. And you're going to see a pretty common trend here, that if you see anything with an alkali metal, so if you have sodium, potassium, rubidium, cesium, and lithium, those are typically going to be soluble, as well as ammonium. So if you see any of those +1 charges that are alkali metals or ammonium, it's typically going to be an exception to this insoluble. Now, if it's anything else, that means it's going to form a precipitate and become a solid when it does the net ion reaction. Now, there are some other small exceptions here, and those are with your sulfides and hydroxides. You'll notice that the strontiums and bariums, those +2 charges, as well as calcium for hydroxide, those 3 will actually be soluble with sulfides or hydroxides. So that's how you use the chart. Now the rest of the stuff, your lab manual and your instructor should cover it fairly well, but if you have some confusion with the chart, we just thought we'd go over it in this experiment. And if you have any other questions, feel free to email your instructor or talk to them in class, and of course talk to your friends and try to figure out what you're going to be doing in the lab. Now that's it for this video. We'll go ahead and catch you next time.